Our next step is to write the bending moment equation. Considering point A as origin, let us take a section XX across the beam at a distance x from point A and move it along the beam from point A, which is your origin, to other extreme point E, and write bending moment equation of all forces and couples in single equation, that is by using Macaulay's method. So we take a section XX at a distance x from your point A. Now considering the left hand side of this section XX, the bending moment at section XX can be written as mxx, which is also equal to EI d square y by dx square, is equal to, a sign convention is on the left hand side of section clockwise moment is positive and anti-clockwise moment is negative. So we have a first clockwise moment due to the upward vertical support reaction VA, which is acting at a distance of x from your section XX. So we have VA into x. Now we also have this anti-clockwise moment due to this UDL of 12 kN per meter acting for a distance of x meter from point A to section XX. So the magnitude of this UDL will act at somewhere at the center at a distance of x by 2 from section XX. So we have minus 12 into x, which represents the magnitude of the force, and it is acting at a distance of x by 2 from section XX. So this becomes the total magnitude of the moment due to the UDL. Now we see that this equation is valid for the section between point A and B. Now as we move the section beyond point B towards right, we see that the first part of your equation is valid, but the second part of the equation, which is for this UDL, becomes invalid. To make this part of the equation valid for the section at all points in the beam, we apply the additional UDL of the same intensity 12 kN per meter for the rest of the part of the beam, that is between point B and E. So we see that now as we move the section beyond point B, this part of the equation remains valid. Now we see that due to additional downward UDL of 12 kN for this part of the beam, the equilibrium of the beam is disturbed. So to restore the equilibrium of the beam, we apply the same UDL on the upper part of the beam and for the same length. So we see the downward UDL and the upward UDL cancels each other. So the shear force as well as bending moment at all points is again nullified. So now we can say that this part of the equation is valid between point A and B, and it will also be valid as the section moves beyond point B. So let's put this part of the equation in first partition, denoting that it is valid only between point A and B of the beam. Now let's move the section XX beyond point B such that your section XX is at the point as shown in figure at a distance x from point A. Now if we write the bending moment about section XX considering the left hand side of section, we'll have the first bending moment as VA into x, and second bending moment will be due to the UDL of 20 kN per meter acting at a distance of x, which is over here. Now as the section moves beyond point B, there is an additional moment due to this upward UDL of 12 kN per meter, which is acting for a distance of x minus 3 meter, that means this much distance. So we can assume the magnitude of this UDL to be acting at the center of this span of UDL, that is at a distance of x minus 3 by 2. So we have plus 12 into x minus 3, which is the magnitude of this upward UDL, and it is acting at a distance of x minus 3 by 2 from section XX. Now we see that this whole part of the equation is valid between point B and C. Now let us consider the section XX between point C and D at a distance x from your origin point A. Now if we take the bending moment about section XX of all the forces and couple on the left hand side of section, we see that the moments due to this upward vertical force, downward UDL and the upward UDL will remain same as shown in the figure. We only see that there is an addition of this clockwise moment of 24 kN, which is acting at a distance of x minus 3 plus 2 5 meter. So clockwise moment on the left hand side of section is positive, so we have a second partition plus 24 kN multiplied by distance is x minus phi to the power 0. Now this 0 indicates that this term comes out to be 1, since we've been directly given the value of the moment 24 kilonewton meter. Now again we see that this total equation will be valid between point C and D. So let's put this in the third partition.